Okay, ladies and gentlemen, today we are talking about volume and surface area word problems. Now we need to keep in mind that these word problems could call for surface area, they could call for lateral surface area, they could call for volume, and they could call for any of our shapes. So we've got all of these equations to deal with, okay, and we need to use the correct set based on the problem. The problem will describe an object, which will be either a prism, pyramid, cylinder, cone, or sphere, and then it will ask a question that will either imply that you need to find the volume, the surface area, or the lateral surface area. So we've got lots and lots and lots of equations that we could have to deal with here, okay? So the first question in our notes says, Aaron is making a jewelry box of wood. And by the way, I did not write these problems, I borrowed them. Aaron is making a jewelry box of wood in the shape of a rectangular prism. The jewelry box will have the dimensions shown below. So it has length of 12 inches, a width of 15 inches, and a height of 6 inches. Okay, or in reality, since it's a rectangular prism, really any of those faces could be considered the base. It doesn't really matter which one. That's part of the fun of prisms, especially rectangular prisms. The cost of painting the exterior of the box is 50 cents per square inch. How much does Aaron have to spend to paint the jewelry box? So here's what we do. With any rectangular prism, well, first of all, we need to decide if we are painting the exterior of the box, that would imply that this is a surface area problem. Now, since it's the entire outside of the box, it's going to be a total surface area problem, okay? If it just said she wanted to paint the sides of the box, then that would make it a lateral surface area problem, okay? And if it were asking, say, how many cubic inches of jewelry can she fit in the box, then that's marking it as a volume problem. So a lot of the challenge of this is figuring out, okay, what shape am I looking at? What do I need to know to find the value that I'm looking for, and what value am I looking for? Okay, so in this problem, we are looking for the total surface area of this rectangular prism. So to do that, we need to know three values. We need to know the area of the base, the perimeter of the base, and the height of the prism. Okay, if we know those three values, then we can find the surface area, because the surface area is 2 times the area of the base plus the perimeter of the base times the height of the prism. So we need to think to ourselves, what shape is the base? Well, this is a rectangular prism. The advantage of a rectangular prism is that any side we choose can be the base of this prism. Okay? Now, the last time we dealt with prisms, you guys had a much easier time recognizing the bottom of the shape as being the base. So we will do that here. But in reality, it does not matter which side, does not matter at all, which side of that prism we call the base. The idea is 2 of those values will form the base, and the other value, in this case 6 inches, will be the height of the prism. And you would get exactly the same answers for surface area regardless of which face on this prism you choose as the base. And that only applies to rectangular prisms, okay? They're sort of the easiest prisms because you can't get the base wrong. You can pick any face you want on a rectangular prism, and it is the base. So I'm choosing the bottom, which is a 15 by 12 inch rectangle, and that will be the base of our figure. So the area of the base would be length times width, or 15 times 12. So we would multiply those together. 15 times 12 would be 180 square inches for the area of the base. For the perimeter of the base, I know there's an equation that says, 2 times 12 plus 2 times. I'm just going to add up the side lengths. If that's 12 by 15, then this side up here is 15, this side over here is 12. and I can just add those together to get the perimeter of this shape as being 54 inches. So the area of the base is 180, and the perimeter of the base is 54. Any questions about where any of those numbers came from? Okay, from there, all we have to do is surface area, which is 2 times the area of the base plus the perimeter of the base times the height. So we plug in our values. Area of the base is 180. Perimeter of the base is 54. The height of the prism is 6. Feed it to the calculator. Two times 180 plus 54 times 6 is 684 square inches. Now, as with any word problem, when you get to what you think is the answer, you should always go back and make sure you have answered the question that was asked. And you've probably heard me say that 1,000 times this year. The question that was asked in this problem is, how much does Erin have to spend to paint the jewelry box? We have not answered that question yet. We have found how much area she needs to paint, but we have not found the price. So that is where the 50 cents per square inch comes in, okay? We are going to take 684 square inches, and we are going to multiply that by 50 cents per square inch. And what that will do is it will give us the total cost in dollars to paint this jewelry box. Then we have to answer with a sentence. So we say Erin has to spend $342 to paint that jewelry box. A little pricey. I think I'd pick cheaper paint. But what are you going to do? Okay. So there is the cost for painting that jewelry box. Any questions on our first example? Again, the big challenge here is going to be figuring out, am I doing lateral surface area, am I doing surface area, or am I doing volume? And then once I have that value, what do I have to do to actually answer the question? So there's our first example. We'll move on to our next one here. If you want a screenshot, grab it now. Generally speaking, Evan, yes, it'll only be one of the 3 equations for whatever solid we're dealing with, okay? Again, our course will run through May 8th, which is 2 weeks from today, so 2 more weeks. Okay. A can of soup is in the form of a cylinder that is 6 inches tall and has a radius of 2.5 inches. How much soup can the can hold? So, again, that phrase at the end there, how much soup can the can hold, tells us what we need to do here. That is implying we need the volume of this prism, okay? So we have a radius of 2.5 inches. So let's label our picture here. Let's put 2.5 inches for our radius. That 5 is terrible, and I feel like I need to fix it. A little bit better. Okay, and we have a 6-inch height for that cylinder. So volume of a cylinder is pi times the radius squared times the height. So from there, we need to find the volume. So we'll say the volume is pi times 2.5 squared times 6. Feed it to the calculator. That would be 37.5 pi cubic inches. Now, the reason I put a cylinder word problem on here is because I wanted to say the following. In theory, that is the volume of the can, so that does answer the question. But I don't know about you guys, but I don't often tell people that my can of soup, well, if I were to say this to somebody, which would be a little off the wall anyway, but I don't think I would say that can of soup holds 37.5 pi cubic inches of soup. I think I'd probably go with a decimal instead. So instead of the exact answer, what we should do is plug in 3.14 for pi. So 37.5 times 3.14 is 117.75 cubic inches. Okay? So we should say the soup can hold 117.75 cubic inches of soup. And in reality, we would probably go with ounces instead, but this is a math problem, so we're just going to roll with it. Okay? So there's our volume. Now our next example here deals with the same can. It says if the can is labeled by wrapping a paper label around the lateral surface of the can, how much paper would be needed to create the label to the nearest square inch? So right there, we should realize that what we're being asked to find this time is the lateral surface area. And the LSA of a cylinder is equal to 2 pi RH. So we plug those in. We say, okay, well, the lateral surface area would be 2 times pi times the radius times the height, or 2 pi times 2.5 times 6, which would be exactly 30 pi square inches. But it does tell us how to round, so we're going to go ahead and plug in 3.14 to get an approximate answer. That is 94.2 square inches. So it says how much paper would be needed to the nearest square inch. So we would round that to the nearest square inch. 94.2 would round down to 94 square inches of paper would be needed to create the label. Remember that with word problems, the expectation is that you will provide a word answer to the question that was asked. Okay? So there's our second example. I think there's only one more. Might be two. Don't quite remember. Okay? So if you want a screenshot, now is the time to grab it because that's a full page of stuff there, and we'll be moving to a new page very, very shortly. Okay. So that brings us to the next problem. There's only one more. Yep. Spaceship Earth. You may have heard of Spaceship Earth before. Yes, it will be on YouTube when we are done. Spaceship Earth is a geosphere at the Epcot Center in Orlando, Florida. It is not really a sphere, but it's almost a sphere. It has a diameter of 165 feet. This problem is asking us how much space is contained within Spaceship Earth. So, as soon as we see those words, that should tell us that this is a volume problem. Remember that the volume of a sphere is 4/3 pi r cubed. So we need a radius, okay? We are not given a radius. We are given a diameter of 165 feet. So to find the radius, we would take the diameter and we would divide by 2. So 165 divided by 2 gives us a radius of 82.5 feet. Okay? 82.5 feet for the radius. So once we have that, this is as simple as us plugging that in for R, 82.5 cubed, and feeding it to the calculator. Now that gives us a really big number, 748,687.5 pi cubic feet. But again, we probably should not bother with leaving the pi in there. So what we're going to do is we're going to plug in 3.14 for pi, which gives us an even bigger number of 2,350,878.75 cubic feet. So we would say spaceship Earth contains about 2,350,878.75 cubic feet of space. Okay, so we've gone through a couple of examples. I want to go ahead and give you the opportunity to start on your assignment. This particular shape is, I forget the exact phrase for it, but it's actually made up of a whole bunch of triangles. So it's not actually a sphere, but it's pretty close. It's as close as humans can build to a sphere of that size. It would be pretty much impossible to build a sphere that size within a reasonable amount of money. But anyway, so what I'm going to do, same thing we always do here. Are there any questions before I stop the video? All right, so we'll stop the recording. Again, the recording will be uploaded to YouTube.